All right, so area, what's area mean? The inside, okay? So the inside of the shape. Now, what do we measure area in? What units? Squared, not cubed, squared. Okay, so square centimetres, square metres, square millimetres. Don't write this down yet, it is wrong. So this, when we do this, we also need to be able to convert between units again. Now, the table which is up there right now is the unit conversion table we had for length before. See how it's just centimetres, metres, kilometres, etc. Okay, we need to change it so that we're looking at square millimetres, square centimetres, etc. So it becomes this. Don't write it down still because it's still not ready yet. Okay, so we've now got to change it to be those measurements. Now, to be able to do that, if we look at this and we go, okay, 1 square centimetre means 1 centimetre by 1 centimetre. Okay, so it's an area of space, which is 1 centimetre by 1 centimetre. All right. If I then break that down into 10, see this little sort of space here. We go 1 centimetre has 10 millimetres in it. Yeah. And so we've ended up with 10 millimetres by 10 millimetres in that shape. How many square millimetres are there? So a square millimetre looks something like this, 1 millimetre by 1 millimetre. Excuse me. How many square millimetres are there in a square centimetre? There's 10. So in that box, how many? 10 across, 10 down? 100, okay? So 1 square centimetre equals 100 square millimetres. Can you see how that works? Centimetre by centimetres here, but the millimetres, there's a lot more because you can fit them all in to that space. All right? So if we know that, we can do the first part of our table, which will soon become right. So if I'm going from a square centimetre to a square millimetre, what would I have to times by? If 1 centimetre squared equals 100 millimetres squared, what do I have to times by to get from centimetre squared to millimetre squared? What do I have to times by? What do I have to times the number of square centimetres by to get the number of square millimetres? It's not times by 10. It's times by 100 because there's 100 in them, yeah? Now, how can I write 100 with 10 as a base? 10 squared, okay? Or you could write times by 100. Now, at the top, we're going to divide by 10. What do you reckon? Is it divide by 10 or is it divide by 10? Squared. What you'll notice is we've got the exact same thing, conversion table. However, everything is squared. So that includes to get from centimetres to square centimetres to square metres. It's divide by 100 squared. It's times by 100 squared. It's divided by 1,000 squared, which is actually 1,000,000, and times by 1,000 squared. That is now correct. Okay, so can you write this bit down, please? I'll do the red ones, which are the actual numbers as well. Divide by 10,000 times by 10,000. Divide by 1,000,000. So there are 1,000,000 square metres in a square kilometre. Times by 1,000,000. But if you think about it, like 1,000,000 square metres, a square metre is a metre by a metre. So if you do a really big step out, so if I go a metre here, a metre by a metre is about from me to the wall to the corner. That's a square metre. A square kilometre is a whole kilometre that way, then a whole kilometre that way. So you can imagine that there would be 1,000,000 of these in that amount of space. Now, if you're getting stuck with how many zeros are in a square, like 100 squared, just know that's just double it. So if, 100, there's 2 zeros, 100 squared, there's 4 zeros. 1,000, there's 3 zeros, 1,000 squared, there's 6 zeros. Because that's how many decimal places you're going to have to move, remembering how we did this with length. All right, so if we have 3 centimeters squared and we want to go to millimeters squared, what do we have to do? Square centimeters to square millimeters. We're timesing by 10 squared. So we're timesing by 100, which means how many decimal places are we moving? 2, the number of zeros, okay? So it's 300 square millimeters. If we go meters squared, square meters to square centimeters, we're timesing by 100 squared, or that's the same as saying 10,000. So this time we move 4 decimal places, and so we end up with 60,000 square centimeters. So exactly the same steps as before. It's just this time the numbers are a bit bigger. There's more decimal places to move. The good thing is, if you can remember the conversion little table we did for length, and you can write that at the top of your page, like at your test, as soon as you get it, right at the top of your page, all you have to do for area is just square everything. All you have to do for when we get to volume is cube everything. And so it's the same little conversion table each time, we just have to change it as we go. So if you can remember the first one, just going 10, 100,000, and knowing which way to go times or divide, these questions should be really easy for you. Any questions about conversions? All right, so we look at area. Now, you'll be given lots and lots of, you'll be given all the formulas on a formula sheet in your test for this. So this isn't about memorizing formulas. I'm not expecting you to memorize formulas. The point is for you guys to actually know how to use them. So I'm going to give you the formulas and we're going to do an example for each one for area. This should be very normal for you guys. You should know them, but I'll give you a few tips as we go along as well. So formulas, formula of a rectangle. Area equals, is everyone finished writing the unit conversions? Okay. Actually, no, I'll keep it there. I'll just make it bigger. Okay, rectangle, area equals length times width. Could you write down the formula? I won't make you write the formulas every time, but just for today. So these are the formulas you need to know for this course, plus a mixture, a combination of them, because remember we can do composite shapes. So rectangle has opposite sides the same, another 2 opposite sides the same. They have right angles in the corner and they are length times width. So if there's one side which is 2 and one side which is 11, how do we find the area? Equals 2 times 11. 22. Now, what measurement will it be? Square meters, always squared for area. Now, if one of those was centimeters and one of them was meters, what would you have to do first? Convert them to the same. So anything we do in measurement, convert them to the same first. All right, then we get to a triangle. Now, most people know area equals half base times height, and you had to use it in your last investigation as well. However, people seem to forget about the fact that it's not just the height, it's the perpendicular height. What does perpendicular mean? Kind of straight. Yep. Any ideas? I think someone said it, but I couldn't hear who. Perpendicular height. Straight line up and down. So what angle does it make with the 90-degree angle? Okay, so perpendicular lines have a 90-degree angle. So it is the straight up and down 90 degrees from the base. And the sort of triangle we often give you is one like this, and we try and trick you by going, well, this is 5, and people go, well, the height must be 5, but that's not, okay? The height is the perpendicular height from the base. See this 9 degrees? That's the height, okay? So area equals half base times height. So for this one, how would we find the area? Half times 2 times 4. So it's 4 square metres. Yes?
In a test, will we ever, we won't see the ghost lines?
We'll often give you the ghost lines for that because we need to be able to show you that it's perpendicular. Be aware that if you ever get given a right angle triangle, the base and the height are always the 2 shorter sides. So a lot of the time, if people, you don't need to write this, a lot of people see like something like this, and they go, the height has to be 10, but it's actually not because it's that perpendicular height. It has to be a 90-degree angle height. If you've got a right angle triangle, it would be half of 6 times 8 or half of 8 times 6. It's never the hypotenuse. The hypotenuse is never included if it's a right angle triangle. Okay? And that often comes up given you guys have learnt a lot about Pythagoras. Any questions? Okay. Circle. Pi r squared. So the area of a circle is pi r squared. It's at this point where everybody suddenly gets confused between the circumference and the area, okay? So you need to be aware that 2 pi r is circumference, it's around the outside. Pi r squared is the inside. If you think about the fact that it's got a squared in there and area is squared, maybe that can help some people. Try and work out something to make sure you remember them, okay, and the differences. So for this one, area equals pi times 4 squared. Can someone just chuck that in the calculator for me, please? Thank you, Callum. Two 6 or 2 5? 2 6 5, so 2 7. All right, everyone okay? All right, so if we then set a sector, so a part of a circle, what do we have to do? Good, okay, so it's still the pi r squared, but this time we just have to find that section. So it's whatever angle it is divided by 360 times by pi r squared. So angle over 360 times by pi r squared. All right, so area equals pi, equals 50 over 360. So we're finding that proportion of the circle, just 50 degrees of a whole circle, times by pi times 4 squared. Which someone's going to chuck in their calculator for me. 6.98. Thank you very much. Square meters. Everyone okay with that? So anytime you get a sector, you're just using the formula for the whole circle and just timesing it by the angle divided by 360. Everyone good with that? All right, we got 3 more. A parallelogram. What's the difference between a parallelogram and a rectangle? Good. The angles aren't 90 degrees in a parallelogram. However, the two opposite sides are still equal on both sides. So this time it needs to be, it's base times, area equals base times height. Again, it's perpendicular height. Don't get confused by the slant height. It is the 90-degree height. Anytime we talk about height, it's always perpendicular height. So for this one, just ignore that little black 4. It's coming from the shape below. This is the red one. So area equals base is 5, height is 6. So it's 30 square meters. You get easily distracted when you sit there. Yeah. I do want you to write the examples down. That's the whole point, because like you have them in a formula sheet. It's not going to help you. It's actually about applying it. All right. Second last one, a kite. Now, can I just get everyone's eyes up this way for a second? A kite is the one which people don't get because it has this half x times y in the formula sheet. And if you can't remember what x and y are, it's going to be really confusing for you. It's the one which people get really mixed up in a test because they suddenly just have a mind blank, okay? With a kite has 2 lengths the side next to each other. 2 lengths the same next to each other. See how these two are the same? And these two are the same. So they're next to each other rather than being opposite each other. Can I just get everyone's eyes up, please? The interesting things about a kite and the things which will help you to decipher whether it is a kite or not is that these two opposite angles, here and here, are always the same. These two at the top and the bottom don't have to be the same. So you can tell where the two differing sides, see how they're different side lengths? Where the two differing sides match up is where those angles are the same. Where the two sides are the same are, they don't have to be. Now, what the x and the y are, it's not a length it's not a length at all. It's not one of the lengths around the kite. It's actually the distance from this angle to this angle and this angle to this angle. So it's the diagonals. It's the distance across the shape and across the shape. So for this one, because this says this is 6 meters from the top to the bottom, and this says this is 4 meters from the left to the right, that is x and that is y. Does everybody understand that? Okay, you may now write. So for this, our area is half times 6 times 4. So it's 12 square meters. Okay, so the diagonals are the distance across the shape. So they told us across the top was 4 meters. They'll tell you. You don't have to like work it out. You just, yeah, it's kind of in the other shape, sorry. All right, last one, and then we're going to put it all together. What's the last shape we're going to look at? No, we're not going to do a rhombus because a rhombus is, no, it is a good shape, but it is like a parallelogram, same thing, base times height. Another one more shape. It is a quadrilateral. Trapezium. All right. Now, a trapezium. The rule of a trapezium, can I just get everyone's eyes up for a second? Trapeziums come up all the time in this course, and the reason why trapeziums come up is the rule for a trapezium is that it has 4 sides. Okay, so it's a 4-sided shape, and 2 of the lines are parallel to each other. So often you look at this shape and you go, that's a trapezium. Everyone looks at that shape and goes, that's a trapezium. However, people don't look at this shape and go, that's a trapezium. But it is. It's got 4 sides and it's got 2 lines parallel to each other. Okay? It doesn't have to have beautifully slanted sides which look all, symmetrical. It can look like this. All it has to have is 4 sides and 2 parallel lines. And these come up all the time. And probably the hardest question in last year's exam had trapeziums in it, and people just forgot how to do it. So just be really aware of that. So the formula for this is half A plus B times height, okay? Now, A plus B are the 2 parallel lines. Okay, it's the length of the 2 parallel lines. The height is the distance between them. Because it's always going to be a perpendicular height there. So if you can remember that, because a lot of the time when you see parallelograms which look a bit like this, people start getting confused and try and use the 4 and whatever this slant height is and things like that. It's the 2 parallel lines and the distance between them, which is in the formula. So for this, area equals half of 5 plus 8 times 4. Now, rather than going half of 13 is 6.5 and then having to times that by 4, which is a little bit hard for some people, it's probably easier to go half of 4 is 2. 2 times 13 is 26, or any other mixture of that around the place. And that's your answer. So instead of, because you've got the 13, you do you've got to do that first. So you're saying half of 13 times 4. But a lot of time if you end up going, instead change it around, go half of 4 is 2. 2 times 13. All right, any questions on the formulas? You will be given a formula sheet, but you do need to know what those formulas actually mean and how to use them. That's the main thing. You're never going to just be asked to do a simple formula. It's going to be about actually applying what you know. All right, so I'm going to give you a question to try. Composite shapes. So could you write, this is the last bit of notes. Could you write down, we're going to find the shaded area. Can you write down steps? Break down what shapes you need to know. Work out the area of each shape and then add and subtract as needed. So this is our shape we're going to do. Can you write the steps down in the shape and then we're going to do it together? You missed one. Good. Just a dotted line. Yeah, you probably don't really need it just there. So if you write the steps down and just draw the shape, and then we're going to do it together. All right, so anytime you get a composite shape, I want you to break it down into the shapes we know. Okay, we don't have a house shape formula. Okay, we have formulas for like 6 or so shapes which we can work out. So what shapes do we know which this breaks down into? And when you get worded questions, that's what I want you to think about too. What is this? What shapes are there which I actually know to be able to work out the question? So what shapes are there? There's a rectangle. And what are the dimensions of that rectangle? 6 by 10. What else have we got? We've got a triangle. And what are the dimensions of that? The base is 10 and the height is? Harry? It's 8 because we've got the 6 and the 14 and what's left over is 8. Okay, so that's most of the shaded region. So we're going to have to add those two things together. What else do we have to get rid of? What do we have to get rid of out of that shape? The semicircles. So we've got 2 semicircles with a diameter of 2. And there's 2 of them, which makes 2 of those becomes a full circle. Once you've broken it down to that, and I draw the little shapes out, these questions are not very hard. Okay? Because we've broken it down into easy shapes. So the first thing I do is I do the rectangle. How do I find the area of the rectangle? Length times width. So 6 times 10 equals 60 square meters. That would give you a mark straight away. How do I find the area of the triangle? Half times base times height. So 10 times 8. So 5 times 8 is 40. And I'm adding them together. So I've got 100 so far. Then what do I have to do? I'll take away the circles. I've got to find the, so pi r squared. So pi times 1 squared is 3.14 square meters. And we're going to take that away. And so in the end, after we've done that, we've added them together, we take it away, we end up with? And that's your answer. Now, even if you show that and you show it step by step, you draw your pictures out. If you make a mistake with the height of the triangle, you just lose 1 mark out of 4 or 5. If you make a mistake with like using the diameter instead of the radius, you're just going to lose 1 mark out of 4 or 5. If you don't show that breakdown and you don't show me what you're doing, then you lose 4 or 5 marks out of 4 or 5 instead. So you're much better as soon as you get a composite shape, draw out the shapes, show me step by step what you're doing, and you can get as many marks as possible. It also helps you in your head. It's not as confusing because you've broken it into easy, achievable steps. Any questions? All right, so you know how you guys did the perimeter of those shapes last lesson? The 8 shapes, questions 1 to 8, exercise 7A, is that right? 8A, exercise 8A. This time you're doing the same questions, but finding the area. Okay, and tomorrow we're going to get straight into more the composite shapes and the worded questions. And we won't have any notes tomorrow, like I said this morning, okay? Any questions? So by tomorrow, I'd like you to have the perimeter and the area for all those shapes, those 8 shapes, please. Can you write that down? Can you keep working? I think we've still got 5 minutes, don't we? Do we? Yeah, we've got 5 minutes, so you may as well get started.